Well, we still have 7 minutes to get started, but given that the room is full, I'll just get started. So welcome to the last day of the conference, and I'm really sorry that we didn't have a bigger room for this talk, so sorry in advance. And thank you very much for coming. How's the conference been so far? Liked it? Looking good? I mean, there's just been so much content that my brain is bursting out of my head right now. I myself have been going to quite a few talks, and the content has just been excellent. Just for context, how many of you were at another session where WebSockets was talked about, like the Sockets talk by Dave Thaler, or the server-side programming for WebSockets by Paul Badum and Stefan Shako, or the IE10 overview by John Hervaden? Okay, so good. Okay, so that gives me some context that you may have some awareness. Well, let's get started. My name is Ravi Rao. I'm a program manager on the Windows Core Networking team. And for Windows 8, I've primarily been working on keeping with the theme of reimagining Windows. My team has been working on reimagining what the networking API surface for Metro-style apps should look like. And a big part of that conversation has been WebSockets and how we enable support for this standard. This is a chalk talk, so I'm going to be dividing up the conversation that we have. You can ask questions anytime. I have a bright light in my face, so if I don't see you, just shout out. I'm going to divide it up into 3 parts. The first is that it first is going to talk about the user aspiration. What do our customers want? What do you, me, want with our connected experiences? I'll then go into WebSockets and how it has the potential of enabling these kinds of real-time web scenarios. And finally, talk about how WebSockets just work everywhere. The standards process, how we interoperate. I'll do some demos across browsers. And we actually have real partners that we are working with today on this effort as well. So I'll go deep, I'll go into the protocol, I'll go into the API, and hopefully you'll leave with an understanding of what WebSockets is. Does this seem okay? Are there other topics you'd like me to cover as a part of this? Because it is a chalk talk. I can be very audience-driven on where you want me to take this. Yeah?
If there's any kind of a mention for the minimum platform requirements in terms of versions of IE and Windows, that would be really helpful.
I will talk to that. Thank you. So the question was minimum platform requirements, versions of IE. I'm happy to bring that up. So before I start, okay, IIS support I will try, but I may not fully answer your questions on that because there was actually another session that was dedicated to that on IIS programming. But I'll talk about it. There's a slide I have on how WebSockets work everywhere, and we can talk about it at that time. So before I get started, I'm going to talk about what you're going to leave with, what I hope you're going to leave with, which is number 1, WebSockets enable the real-time web. The point being here that information is available to the user the moment it is published, the real-time web. WebSockets are standards-based. This is a standard. They're interoperable across browsers, and they're very simple to use. And the fact that WebSockets are just everywhere. We think they're so important. We've added support in the browser, in the Windows runtime, in the server, IIS, ASP, WCF, System.net. We've provided support for WebSockets everywhere. So those are the 3 things I hope you will leave with at the end of this session. So let's start with the user aspiration. One of the things I have seen recently is that all of us, me, all my friends, all the people I know, my kids, my 5-year-old son, has a deep desire, has a deep need for speed. And I'm not talking about fast cars, even though my son wants a Ferrari already. I'm actually just talking about what we expect from the network. We started with dial-up, DSL, cable, Fios, I don't know, 5 megabits, 10 megabits, 15, 20. I'm at 35 megabits up and down right now in Seattle. And I know in Korea, apparently, they do 100 megabits per second up and down. So there's this deep desire for speed, deep desire to get information as quickly as is possible. Now, there are two dimensions to this. The first dimension says that when I go and try to get content, I want it to come back down to me as quickly as possible. When I download that 6 GB Lord of the Rings movie, I want it, when I rent it, I want it to come fast to me. The other aspect, though, of this is that the moment information is available on a server somewhere, I want it available to me immediately. If a session gets canceled, I want to know about it immediately. If my son's school bus gets canceled, I want to know about it immediately. All the craziness going on Wall Street, I don't know, debt ceiling and mortgage crisis, I guess, and all kinds of things that I don't have a clue about, I want to know about all of that immediately. You know, all the Wall Street craziness, sell, sell, buy, sell, buy. I want to know about all of that immediately so that I can do something stupid. You know, I watch a lot of games on the internet. You know, I watch cricket. I don't know how many of you know about cricket, but it's woohoo! It's a great game. And I watch, the way I typically watch it is I have a page on which I can see the scores when my country plays against another. And I want to know how my country is doing. Now, I want to know every time the score changes what the score is or what the commentary is. I don't want to know 30 seconds later. I don't want to know 10 seconds later. I don't want to know 5 seconds later. I want to know it immediately. Air traffic controllers want to know where their planes are at all times. When I do a Twitter search, I get a set of results, but Twitter keeps streaming me results back. It wants to keep you current on new results that are coming through. If new mail, you know, you have mail, I want to know that immediately. I don't want to know that later. If I'm playing a game with my mom in India, I'm playing Scrabble with her, for instance, I don't want to have to wait a minute before I know it's my turn to play. I want to know that it's my turn to play immediately. If someone posts something on my wall, I want to know about that immediately. This human desire to get information as quickly as possible, as immediately as possible, as real-time as possible is what the real-time web is about. The question is the web ready? Is the web ready for something like this? Was it designed for something like this? So the web is 20 years old. It's pretty old. The protocol, underlying protocol used on the web is HTTP and has a pretty simple model that has worked fairly well. You make a request to a server and says, please give me something, give me a page, give me a document, give me a movie, whatever it is, and the server sends it back to you. Very simple model. The problem is that this model of request response doesn't necessarily scale well when you look at real-time web scenarios. Say, take the game I'm watching on the internet, where I'm tracking scores. I talk to the server and say, what is the score? Server says, it's 3-0. Let's say I'm watching a soccer game. The score is 3-0. I'm like, okay, I've not heard anything. What's the score now? Nothing has changed, still 3-0. Yeah, but what's the score now? Nothing has changed, still 3-0. Shut up, will you? I mean, how many times are you going to ask me? So I'm reminded of my kids. I mean, I don't know how many of you have kids sitting at the back of my car saying, are we there yet? No. Are we there yet? No. Are we there yet? No. And if you watch the Simpsons episode on this, okay, I hear some chuckles. That's pretty hilarious. So the problem is that real-time web scenarios need the server to be able to talk to the client asynchronously. They don't want to have to wait for a request from the client before they respond. The server has to be able to push data down to the client as fast as they can, whenever they can. HTTP, on the other hand, is a request-response protocol. The server can only communicate with the client when the client makes a request. Okay? So this is called polling, where the client, in order to get information as quickly as it can, the client constantly polls the server. Do you have new information? Do you have new information? So on and so forth. Now, polling isn't necessarily bad. I mean, polling gets used very often. And a great example of this is Bing search. When I start typing in search, when I start typing in the Bing search box, it starts giving me hints on what you may be looking for. So what should I look for? Cricket. Okay. C-R-I-C-K-E-T. R-I-C-K-E-T, cricket, right? And you noticed as I started typing, Bing started giving me suggestions. And the way it does that is every time I type something, it sends it up to the server, and the server then says, OK, based on what you're looking for, these are the kinds of search results you have. Now, for sending, let's see, that's 7 characters. 7 characters of information to the server. That's all I have sent. 7 characters, 7 bytes of information to the server. How much HTTP overhead do you think there is? 7 bytes? 70 bytes? 700 bytes? Let's take a look. I'm going to open up developer tools, the F12 developer tools in IE. I'm going to go to network, and I will zoom in, so just be patient. And I'm going to start capturing. I'm going to start typing. C, R, and you can see the GET request going out. I, C, K, E, T, cricket. Now, if you want to see how much traffic that generated, just based on headers, that is almost 4 kilobytes of data for sending 7 bytes of data on the wire. We should be able to do better. Now, you may, of course, I know what you're thinking. You may be thinking, oh, that's Bing. The other search engine must do better, right? I'm sure it does. Let's try it out. OK, the other search engine. Let's try that. So I'm going to clear this. OK, and I'm going to type the same things. C, R, I, C, K, E, T. And the number for the other search engine, for ours it was 4K, if you remember, 3 point something, is 19 kilobytes of data. Now, I'm not bringing this up to bash great products. I really am not. Both products are great products. I bring this up to point out that polling is a reality that some applications, some sites are going to have to use. But the mechanisms used have a lot of overhead. We should be able to do better. OK? Back. So in other words, now, workarounds exist. So we talked about polling as a potential workaround for getting real-time information from a server. There are other mechanisms that are in place. There's long polling. Long polling says that, or HTTP parking, as someone else had used the term, where the client sends a request to the server, and the server holds on to that request. It holds on to that request until some information is available, and then sends a response back to the client. And then the client immediately posts the request to the server, and the server catches it, holds on to it, and then when information is available, sends it back. Feels unintuitive. There's all the overhead of HTTP still associated with it, and the server is having to hold on to these requests for, I don't know how long. It's a weird programming model. And if data is coming through really, really fast from the server, then this model does not scale very well, as you can imagine. More sophisticated examples of this are where there are multiple channels between the client and the server. So the client opens 2 channels to the server, not 1, but 2. One is meant for the client to talk to the server. The other is meant for the server to talk to the client. Okay, so both sides, in theory, can talk to each other in parallel, right? Sounds like a great idea. Well, you just cut your server scalability in half by doing that, because now you have 2 connections open instead of 1. And what's worse is if your data center has a reverse proxy or a load balancer sitting at the edge, you have no guarantee that each connection will go, these 2 connections will actually go to the same server. They could get load balanced out to different servers. And now you have to do affinity-based things. You have to provision those actual load balancers at the edge of the gateway. And it starts becoming complicated. And there are other models. And in the end, all of these fundamentally are hacks. They're hacks on a protocol that really was just never designed to support a scenario like this. In other words, HTTP by itself, by design, is not adequate for supporting the needs of the real-time web. Before I move on, are there any questions? Any questions on the problems with HTTP, how this back and forth process actually works, the overhead associated with it, and why we need a different or a better solution. We're good? Everyone with me? Okay, awesome. So let's move on to the next part. WebSocket. So WebSocket is an enabler of the real-time web. How did these form? How did this happen? So the idea is that some of you may be familiar with sockets. How many of you are familiar with sockets? Wonderful. So everyone knows about sockets. Sockets are a full duplex bidirectional protocol. Both sides can talk continuously with each other. They have, as a result, they have the richness that's needed for real-time apps, because if you have a socket, the server can be sending anytime data it wants to the client. The problem is sockets are not directly available to web developers. So if I'm in the browser and I want to use sockets, well, you can't. The only way you can do that is by installing some kind of a control, whether it's Flash or Silverlight or what have you. You need some kind of a control in order to use sockets. And in the HTML5 world, controls are not something we necessarily like. Well, that was putting it mildly. In addition, if you have sockets, they typically get blocked by proxies, because proxies allow HTTP traffic to go through, but they just block all other protocols from going through. On the other hand, HTTP, which actually layers on top of sockets. HTTP is a protocol that just uses sockets underneath the covers. It has reach. It works through HTTP proxies, but it's not rich enough for all the reasons we talked about for real-time web scenarios. So what we need is a mix of the two. You need the richness of sockets combined with the reach of the web. And that's how WebSockets came to be. And I will go into the protocol, but the way the protocol works, or what facilities it provides, is it's a full duplex bidirectional communication channel between the client and the server. It supports both secured, so it uses TCP underneath the covers, and or unsecured, which uses TCP, and secured, which would use SSL underneath the covers, TLS to be precise. It can traverse proxies and firewalls when it uses SSL or TLS, because until the ecosystem evolves and moves with us, proxy traversal will typically work when you're using TLS. It has this notion of ping-pong messages. So a gentleman, Noble, was asking in the front about how do you keep the connection alive? If there is no data flowing for a certain amount of time, how does the connection get kept alive? Well, the protocol itself has inbuilt capabilities to do ping and a pong, so that the connection stays alive because there's some data flowing over the connection at all times, or at periodic intervals. And these ping pongs have the benefit of being end-to-end. So if you have a client going through a proxy, and then the proxy is connecting to your actual server, the server may choose to disconnect, and you may never know about it. Ping pong has the benefit that it's end-to-end, so it will flow all the way to the server and server all the way back to the client. So within the protocol, we built in capabilities, the standard has capabilities to ensure that the connection stays alive. And finally, it supports the standard origin-based security model, meaning that the place where the server is going to make a decision on whether an incoming request from a script is going to be accepted or not, based on the origin of that request. So again, pretty standard. Let's go into the protocol. So far, so good? Again, okay. So the way the protocol works is you start with HTTP. And you have to start with HTTP because that's the only thing that will get through proxies. It could be HTTP, it could be HTTPS, either, because WebSocket supports both modes. So you start with HTTP and tell the server, hey, I want to do this new protocol, WebSockets. The server says, does its needed checks that it wants to do, and says, okay, let's do WebSockets, sure. And once this server accepts the incoming request from the client, both of them now drop down and use the underlying TCP socket that HTTP was using. So it's pretty clever. It starts with HTTP, and then when both sides accept that they want to do WebSockets, it comes down and starts using the underlying TCP socket that was used by HTTP. Okay? So now, what I will do is I will go into Netmon and quickly show you a drill down of the protocol, what it looks like. So you have a sense, just a brief, quick view into how the protocol operates. So this is standard Netmon. So I have a wire capture of a client talking to a server. In the top frame here, you see all the frames. These are all the frames that are flowing over the wire. This column here, this column is the protocol, so it tells you what protocol is being used. And this is just HTTP. So whatever you read there, just read it as HTTP. In this section over here, you see a breakdown of that protocol into its headers. So this section will go into TCP, what the TCP headers are, what the HTTP headers are, so on and so forth. And finally, on this side over here, you have all the raw bytes. Okay? It's pretty standard. So what we'll do is let's drill down very quickly into what a request, a handshake request from the client looks like. So this frame that you look at, if you look here now, you'll see that it's a pretty standard get command. You have get going on the wire. It has a URI. It has a protocol version, the origin for origin-based security. It then specifies a sub-protocol or a protocol it wants to do on top of the actual socket. So you have socket, and now the app can say, I want to do, or I support both simple chat and awesome chat. I support both the protocols. What do you support, server? And it sends it. And the server can now respond back saying, I actually support this particular protocol. It has a security key. And the security key is to ensure that both sides actually understand WebSockets. Okay, so it's just a defense in depth to make sure that the client and server, when they talk to each other, they both actually understand the WebSocket protocol, so that you don't have a client sending arbitrary TCP frames over to a web server on the internet. And then these are the two keywords: connection upgrade, upgrade WebSocket. This is what tells the server that this client wants to do WebSockets. And finally, there's a version. So it's pretty straightforward. That's what the request looks like. And the response to that looks like this. The server sends back a message saying, yes, let's do WebSockets. Let's switch. We're going to now switch protocols to doing WebSockets. You again see the upgrade header. Same two things repeat. The server picks the protocol it wanted to pick. It picked chat, and it responds with the security key as well. It does some math on the server, and I can go into that if you'd like later, and it responds. And at this point of time, the connection between the two is established, and both sides are going to start doing WebSockets. And if you want, you can see that here. You can see that hello world. If you look at these bytes here, you can see that hello world is getting sent across. Okay, so both sides can now start communicating with each other. Make sense? Okay, great. If I'm going into unnecessary detail, this is a chalk talk, so you can take me wherever you want to take me. So just tell me, this is just pointless. Show me how to build apps, and we'll go there. Okay, so that was a protocol drill down. So the protocol is, again, very straightforward. The client sends a handshake request to the server. The server responds to the client. And now they both drop down and start using the underlying TCP socket. So now what can they do on it? So the WebSocket API is defined in at W3C. And Microsoft is an active participant in the definition of this API. And the programming model is really, really straightforward. The programming model is completely event-driven. So if the connection is opened, you have an on-open callback that gets triggered. The moment you receive a message, you have an on-message callback that gets triggered. If the connection gets closed, there's an on-close. If there's an error, there's an on-error. Very simple. And to establish the WebSocket connection, there is a constructor, WebSocket, which takes in the URI you want to connect to, and it takes in a set of protocols. So the client can say that I want to chat. I can do, as we talked, I can do various versions of chat, and the server gets to pick. And finally, there's send for sending actual data, which could be UTF-8 text, or it can be binary. Binary being blob or array buffer. Okay? Okay, so let's go into a demo. Okay, so I showed this already. Okay, I'll close this. Did you know this is a fungus and that it's actually edible and that they're serving it for lunch today? Okay, I was kidding. Okay, so let's start a very simple application I wrote, Echo. So all this does is I have a server on my local machine. So I'm just doing everything local just to keep it safe. Networks can be sometimes untrustworthy. So I have an Echo server that's running on my machine, and I have a browser client, and you see this is what the page is. And all this page is going to do is it allows me to type in whatever I want to. And I type that in. This message is now going to go to the server, and the server is going to echo it back. Okay, because the server is also excited about developers. Okay? So that's all that's happening here. So the message goes to the server is going to echo it back. The client is now going to get its on message fired, and when its on message is fired, it's going to write it to the text box. And we will see that in operation. Another one is I can do binary, and so here I can draw something, and I'm a terrible artist. I can draw that, an umbrella, to remind me of the Seattle days that are coming up. And I can echo it. So I can echo it. The same process happens. The image went to the server, the blob went to the server, comes back down, and I'm showing it in the box in the canvas right next to it. So now let's look at the insides of how this works. And for that, what I'm going to do is I'm going to debug this. So I'm going to again open IE's developer tools, and I'm going to go into script, and I'm going to set some breakpoints so that just to make it easy for us to look at everything. So I'm going to set some breakpoints. So that's the onMessage function where I'm setting a breakpoint. I'll set an exception on sending a text message, set a breakpoint on sending binary. And that should do it. And now we'll start debugging. So the first thing that happens, and I will zoom in, is I'm going to set the URI that I want to communicate with. Now what you'll notice is that this has a special scheme name, WS. WS indicates to the browser that this is not something that goes on the wire. It indicates to the browser that this is a WebSocket request coming in, and you need to do the HTTP handshake dance before anything else happens. So WS never goes on the wire. It's HTTP that goes on the wire. The scheme name is simply telling the browser that you need to have new behavior, different behavior. Okay? And then as you see here, this is the host name, the service name, AT, or port number, and then that's the actual server I'm talking to. Pretty straightforward. I set the protocol I want to use, so I'm saying I want to use my protocol, and then I create a WebSocket. I pass in the host, and I pass in the subprotocols. And when I come out of this, a socket is going to be created. So either it's going to succeed, which I hope it does, or it's going to fail. And if it succeeds, and okay, right now it's just going to load this. It succeeded. So now I'm back on my page because the socket got created. I'm back on my page. Is this making sense? Yes? Okay. So now I type something in here. Let's say I type in just text, and I say echo. I'm going to now go to send text message. And again, now it's going to check what the ready state of the socket is. Is the socket open? There are many states, and you can just check the API documentation for that. But the most important state is the socket open? So it checks the ready state, and it now gets the content, basically the value of what is in the text box, and it calls socket.send. As simple as that. Make sense? Now I go on, the message got sent to the server echoed it back, and now you notice socket.onMessage gets triggered. It checks to see, is this a blob? That's the first thing it checks. Is this a blob or is this text? Because in the protocol, every message is associated with a type. A message can be text, it can be binary, it can even be a control frame, like ping pong messages. So it says, wait, this is not a blob, this is text. So it comes down here, and now all it does is it grabs the text box pretty much, the destination text box, and it writes the value down there. Make sense? Now if I were to draw something over here, and I try to echo that, it now it goes into send binary message. It goes into send binary message. Same set of tests. It's now going to get the source canvas. Now it's going to call. Now what it actually wants to send, because it can send a blob. Array buffers are typically used when you want to parse what is inside. You want to parse the information. It's like an array. A blob is something that's opaque. So you just want to send it to the server, and you want to get it back. That's all we're trying to do. So for this, there is a special method, which is canvas to blob. Now, to blob is currently a proposed standard. It's not a standard yet. So that's why we have a prefix in front of it. This is a pretty common model in the web world to prefix APIs. That's why we have a prefix there. And hopefully, it will become a standard soon enough. So we took the canvas, which had B8 on it, converted it to a blob, and then we're just going to send it. Again, a message got received, onMessage got called, and then standard set of steps. I'm getting the destination canvas, I'm getting the context of the destination canvas, and now I'm going to use a standard model for loading the image onto that canvas. And that's it. Make sense? Okay. So now you may be thinking, okay, this is fine, but this was a really simple app. This is not real-time web. It actually is, actually. I don't know if you've used IAM. I'm not much of an IAM user, but when I was using IAM some time back, I would constantly see this message, John is typing a message. Have you seen that? At the bottom it says John is typing. How do you think it gets it? It's polling, constant polling the server. Is John still typing a message? Is John still typing a message? So even this simple scenario can be a real-time web scenario. But let's take something that's fancier. So let's take a scenario of a stock ticker, which is pumping a lot of information. It's sending as much information as it has down to the client as fast as it can. And let's see what we see there. So I have a stock ticker server. And you can basically see here that I have no latency. So that is one thing I would like to bring up, that there is no latency here. Oops. In the actual simulation. That data is simulation, not simulation, real code. There's no latency involved here. Server is sending down data as fast as it can. There's no latency between the client and the server. And the client is consuming it as fast as it can. And in the time I've said all this, there's already been close to 2,000 updates. So there's information flowing down really, really fast. And I can jack it up. I mean, I have these plus minus buttons here to increase it more, and it'll speed up. And you can see WebSocket is pulling away from polling, even though there's no latency at all. And the client is making like an unlimited number of requests to the server, which is not realistic for polling. Let's look at what the code for this looks like, just to see, building such a scenario, what the code for this looks like. So again, I'll just bring up the debugging tools. Script. I'm not going to debug this. I'll just show you where the code here is. I'm going to show you the code here. So I have a function connect WebSockets. This is the URL it's connecting to. which is currently the local host. And then I'm instantiating a WebSocket. I have an onOpen trigger, which just says connected. This is the small amount of code for when I want to jack it up, increase this frequency at which I'm getting updates. I have a close, and I have an onMessage. And in onMessage, the data I'm getting back from the server is formatted as JSON. So I have a JSON.parse to get the actual data associated with it. I get the time, the current time, and I just append it to the graph. And that's it. As simple as that. And if you think about that, you're getting 9,000 updates in the time I did this demo. 9,000 messages have flown between the server and the client, and it was that simple to create. So that's just the power of WebSockets I want to show with respect to how much information you can send across. The server can be pushing across to the client with the client code still being so straightforward to do. Any questions on this? Yeah.
There's just one request from the client, and then there are 9,000 response back from the server.
Good question. You're asking about the polling behavior or WebSocket behavior? WebSocket. So the question is there one request from the client and 9,000 responses from the server? The answer is yes. With WebSockets, what will happen is the initial handshake is going to go through, and now you have a TCP connection underneath the covers. Now the server basically is just sending 9,000 as fast as it can, and it sent 12,000 messages already. Now when I press the plus button here, that is actually a message that goes to the server while the server is sending stuff down. It's a message that goes to the server, and the server uses that information now to say, okay, I need to increase the frequency at which I'm sending, and now increases the frequency and sends it down. Does it? Yeah. The frequency is up to the application. So I use this app, this page more as a proof of concept of what you can do, because I have seen stock tickers that go up and down like that. Yep.
What versions of IE will this work on?
Okay, thank you. So the support for IE is only on IE10. IE10 will have full support for the standard. Yeah, that's about all I can say. And IE10 is on Windows 8 only now, and I don't know if they have announced further plans, but I'm sure they have plans for IE10 that I don't know about. But IE10 is what it's going to work on, and this, well, just so that you can see it, I'll start it up on the other browser. Let's close it. So let's start it up on Chrome. And I don't remember do I have it here? I think that's the one. And you can see it's exactly the same thing. Works across browsers, because it's a standard. It just works across browsers. Sorry? Good question. Very good question. The question is, weren't you using a prefixed API? Because I just showed that to you. The prefixed API, I showed it in the sample where I had binary, the echo sample. If I needed, and you can see it's a little choppy, maybe because it's not hardware accelerated. I'm serious. But I think you make a very good point that if you want to be sending binary across, then there are ways of doing it. I've just not looked into it. I know there is a way of doing binary in Chrome as well. So, but blob in Chrome, yeah.
You see it works across browsers, specifically what versions, what browsers?
Okay, so what versions? IE10. The other browser, Chrome goes through version numbers pretty quickly. But I think Chrome 15 and up supports binary as well. They were only supporting text for the longest of times, but just recently I think they have added support for binary too. And it's not the current version of IE10 that is on your Samsung Windows Developer Preview PCs. That has IE10. So shipping to the extent that we're providing it to you now. And Chrome, it's basically, I don't understand the Chrome cycles very well because their version numbers change very rapidly, so I don't understand their ship cycles. But their shipping version, my understanding is like Chrome 13. Chrome 13 has support for text. It does not have support for binary.
So if we wanted this to work on Windows 7 or Windows Vista, it would have to be Chrome.
If you wanted to work on, currently, if you want this to work on Windows 7 or Vista, it would have to be Chrome. Yes. But that may change. And yep.
So on lifetime of socket is from time you open the socket and from time to the time you close the socket.
That's correct.
So if I have millions of users open up their browser and access my web application, I'm going to have a million socket open at the server side.
Yeah, so the question is, if you have millions of users who are trying to access information from my server, do I need millions of connections open? And the answer is yes. WebSockets is going to require an open connection on the server. So it really depends on your scenario. If your scenario is you are sending information to a lot of clients, then you probably need those connections open anyway. If your scenario, on the other hand, is I'm only sending information once every hour and the client can just poll for it, then that might just work. Then that might work better. So WebSockets is not trying to solve every problem that is out there. Polling has its place. And if you have information that trickles down periodically to some clients, then maybe a polling-based approach is better. Yep.
What frequency would justify using sockets over polling?
The question is, what frequency would justify using sockets over polling? That's a very difficult question. I really don't know the answer to that. I think it's no, you would not be able to poll this fast. No chance. I mean, there's no latency. I'll show you a demo soon when I actually add some latency. That'll look horrible. So I'm sorry, I just don't have a good answer to question of when you use sockets versus polling. It's just going to depend on your scenario. The main thing I can say is if you have notifications or data that has to get sent to a number of clients and you think it's somewhat frequent, then okay, then WebSockets is the answer for something like this. Absolutely.
Another question is there's
Yeah.
throttling built in.
If
There's throttling built in.
okay, is there?
Overload the client? Or does the
It's TCP, so TCP will auto-adjust. I mean, all the congestion control mechanisms that are built into TCP will apply here as well. Yeah.
At what stage is the finalization of the spec? Because early on there was issues with
Great question.
security and
I'll come to that. The next section goes into that. I will, if you could hold your question. Yeah. Was there another question here? Yeah. The promise on CPU and memory, we're still measuring. I cannot say that right now. Our hope is that it'll be similar to what TCP uses or something in that ballpark, that if you have an open TCP connection, it uses a certain amount of memory. WebSocket connection, maybe a little more, but something in that ballpark. That's our hope. We have not measured yet. Great question. This talk is actually not focused on the server side. This talk is focused on the client-side programming model. What I would suggest is there is a great talk that Paul Batum and Stefan Shako gave, which I have in my list of links. I would highly recommend you watch that video. It's a great talk. They did a really, really nice talk. Were any of you there at that talk? Okay, yeah. Wasn't it a good talk? Yeah, it was a really good talk they gave. So I'm not going to be going into ASP, which I'm sure a lot of people, or WCF, which I'm sure you're interested in. That's the topic of a different session. Okay, so let's see. Okay, so I'm going to switch back. So far, so good? Making sense, everything, more or less, on a Friday? Okay. So again, just to very quickly recap what we saw, WebSockets enables real-time web scenarios with a full duplex bidirectional channel that's available. It's lightweight framing. It's very, very lightweight. So on top of TCP, there is some framing, but it's relatively lightweight. And hopefully you all saw that the API is very, very simple to use. Programming model is pretty straightforward. So now I'm going to go into interoperability and hopefully answer the question the gentleman there asked. So when it comes to standards and interoperability, we tend to have a fairly deliberate approach. We don't tend to add support for evolving standards very quickly into the browser. We actually want to wait, and I'll talk about the process of adding things into the browser so that once it's there, developers can trust it's going to stay there. Okay? So the model we use is we first experiment. So there's an evolving standard, looks cool. We may have driven some of it. We have a site called HTML5 Labs, html5labs.com. And this site we provide updates to the protocol as the protocol is evolving. So for instance, the WebSocket protocol, if some of you have followed it, I mean, before it even hit the IETF, went through 76 versions. And that's how much it evolved. In the IETF, it has gone through 13 versions and is stable now. It has gone to the IESG for getting approved. So we first experiment. And what we do here is we put out apps, sample applications. We make them available for you to try out. You can try out. You can build things. You can give us feedback saying, yeah, you know, this API doesn't quite work. I need this capability. Or this protocol, need to add something else into it. We can now take that feedback based on real customer feedback and drive it into the standard. So that's the purpose of having HTML5 Labs. Now, once the standard starts stabilizing, we create an app, a good app that basically makes the point about what is this feature about. So we call them test drives. And if you've gone to IE test drives, there are a set of beautiful applications you can take a look at that demonstrate the various HTML5 capabilities that we are providing support for. And I'll show them. I'll show a WebSocket one to you. Once we create an app, we next validate. And we are pretty diligent about not just testing locally, but helping the community by providing a comprehensive test suite that can be run across multiple browsers. So we provide a test suite. In fact, other vendors provide a test suite too. And periodically, these test suites get run across all the browsers to ensure that there is compatibility and interoperability across all of them. And once there is a degree of comfort that, yes, this thing is looking interoperable, this is stabilizing, we provide full support in IE at that time. And given the fact that we are providing support in IE now, is basically saying that the standards are stable. Or the protocol itself is now, if you're familiar with the IE process, with the IETF process, has left the working group. It has gone up higher to the IESG, the standardization group, which may have some comments, and then we get the stamp of approval, becomes an RFC standard at that point. And the API is very, very, very close to last call. So the API is also pretty much done, and the API hasn't changed for a while either. Does that answer your question? Yeah? Are you sure? Did it go in the last few days? It may be, okay. You have more real-time information than I do. Okay, so now what I want to do is I just want to switch again, because I just wanted to make this demo heavy, and show you the test drives. So one of the test drives we created is a flipbook. Does anyone know what a flipbook is? A flipbook is a series of images, series of pictures that when you look at them fast enough, it looks like it's a motion video. Okay, so kids love them. You know, you just quickly whip through pages and you can see as if something is moving. So we made a flipbook because it involves images having to flow down fast. It gives us control. We can try to send down 5 images a second, 20 images a second, 30 images a second, and see how WebSockets does, how polling does. It gives us the ability to add latency. What if this round trip was actually non-zero? It actually took more than 0 milliseconds to go from the client to the server and back. It allows us to play around and see how, what the behaviors are. So let's look at polling to start with. So let's say I use, so you can see that here, this is set at 5 frames per second. You can't see it, just believe me. This is setting at 5 frames per second, and there is no additional latency. So when I play this movie, images are now coming down from the server. This is, imagine a whiteboard session happening between 2 colleagues where he's presenting to his colleague somewhere else. Now the colleague says, what? No, it should be that way. And this, again, is a real-time web scenario that we're showing in the form of a flipbook. What happens if I increase the frame rate to much more than that? Let's say I just go max on it. Let's say I go all the way up to 30 frames per second, or 30 images per second. How does it do? Well, it certainly speeds up. It's going up to 18 frames per second is what it was able to give us. Now, what if I add some latency? Let's say I add some latency which is within the continent, within North America. So that's about 100 milliseconds. 60 to 100 milliseconds is what east to west coast is what you see. And now let's try this and see what we get. Now the client has to make a request, get an image, send a request, get an image. Things start becoming choppy. You're getting only about 3 or 4 frames per second because the client has to make a request. Now, in theory, I could make this better. I can have multiple requests going out so that the client can be getting the images as quickly as possible, but now you're impacting scalability of your server. So it's a balance, and you have to figure out that balance. And if I try it out at 250 milliseconds, let's say I go transcontinental, now the behavior of polling here will be appalling. And this is just depressing. And I'm just going to let it go on, because I don't have an easy way to pause it. The other person really wants to make his point, so we'll let him make his point. And after this finishes, I'm going to try it with WebSockets. And let's see what happens with WebSockets, where the server can basically just keep sending these images down one after the other. So yes, there is the initial latency of 250 milliseconds, but so the first image will come at the 251st millisecond, but the second image, because the server is sending immediately, comes at the 252nd millisecond. Let's see how it looks. Ready? Don't blink. Done. That's the power of WebSockets. Okay, so that was a test drive. So that's what we put on the web so that people can play around with it. And if you just go to the test drive site, which I have here, I think that's the one, you can see we have a whole bunch of test drives. Yeah, and some of them are really cool. I mean, not that this one isn't, but some of them are actually cooler. Totally worth looking at it. Now, the next thing I just wanted to quickly show, as I said, was a test suite. So we've submitted a set of tests. These are currently on MSDN, and these are going to get published at W3C in the near future. And if you look what we've done here, we have let me just open the right tab. Okay. I'm assuming people behind cannot see this, and that's okay. You're seeing colors, I assume. Green is good, red is not. And what we have here is the first column is IE10. And this test suite tests against shipping versions. So someone asked a question on what version of Chrome. This is testing against Google Chrome 13 and Safari 5.1 and Mozilla 6.0. Okay, so that's what it's testing against. And at present, and this data is not up to date. Again, I don't want to just give the wrong impression here. But IE10 is doing fairly well right now. Most of the tests are passing. It's pretty green in the first column. That's a good thing because we care about providing solid implementation of the standard. And the other ones are also doing pretty well. IE9 on the last column is obviously red because there's no support. But everyone else, there's some reds, but the reds primarily exist for the others because they have not implemented support for binary yet. And Chrome already has. I mean, Chrome actually has implemented support for binary in 15 or 16 or something. So it'll come. Yes, sir? I want to make sure I understood your question. Are you saying how do you separate out when you're building your app? You want to know what browser you're running on? Got it. Absolutely, absolutely. So I think honestly the way we have approached the W3C spec is that there are no shoulds. There are no mays. Everything is a must, to ensure that when someone says they comply with the standard, they are fully compliant with the standard. And so you should assume that this chart is going to become very green, completely green probably, in the next few weeks or months. Not very long. It's going to become completely green because everyone, all the browser vendors are in the forum where we're defining the standard. Google is there, Mozilla is there, Apple is there, we are there. Everyone's there. And so this chart is going to become green. So you should be able to assume that the set of APIs that are defined in the W3C spec are available for you to use. Yeah. Yes, so the question is there an IE10 Explorer, IE10 release before Windows 8? I honestly don't know the answer to that. Yeah.
Can I just make a comment
Yep.
on that?
Yeah.
You know, like jQuery and these other libraries,
Yeah.
there are some people out there that have done libraries that take into account some of this stuff.
Okay.
And like there's a good library called socket.io.
Yeah, I love it.
That
Yeah.
Takes care of some of these
Yeah.
things that don't work on one browser
Yeah.
versus the other.
Yes. So I think gentleman in front was making the point that there are libraries that try to abstract away what works in one browser versus another. That is correct. My hope is it doesn't come down to that. Socket.io, I'm sure, will produce a great library. But my sincere hope is that we will have a green chart. Lastly, I don't want to miss this. I want to talk about our partners. So standards are nice and dandy, but partners is what make them real. So the first demo I'm going to do, Yeah, I'll just demo it, is a demo of a product from the company Ericom. So Ericom basically creates products for application and desktop virtualization. And they have a product that lets you do desktop virtualization in the browser. So your desktop is not running on your desktop. Your desktop is running somewhere in the cloud. That's what virtualization is all about, or another machine. And you're getting a view, pretty much, of that desktop in your browser. So does that make sense? It's kind of... Remoting technologies take a second to, did that really just happen? So I'm connecting, a WebSocket connection is being made, and if you notice now, I am on a remote desktop. There's a start of a horribly old operating system. Oh my God. Okay. And then you can access your desktop. This is your desktop. This is your desktop hosted remotely. Now, the reason I think this is especially interesting is because we've been talking about so many scenarios here. I've talked about Facebook, and I've talked about Twitter, and I've talked about airlines. But these folks and Citrix, who I will also demo, have just thought of new ways in which you can use this wonderful technology. There's so much data that has to stream. Imagine I'm playing a video here. That video has to get streamed down to the client as quickly as possible. Well, if you want to show it in the browser with no additional add-ons or installs, you need to use something like WebSockets. Another demo I would like to show is Citrix. How many of you were at the IE10 overview talk by John Hervatin? Very few of you. Okay. Ben from Citrix is here, by the way, in case you wanted to talk to him. So this page takes a little bit to load, but again, if it loads, okay. It really wants to open Ericoms, Ben. Okay, this takes a little bit to load. But again, the idea is again the same. A key element of Citrix's strategy is to have the ability for people to virtualize their desktops and applications. And the way they do this is with the HTML5 receiver that they have built that's available all over the place. With WebSockets, they found a neat model by which they can provide support directly in the browser. The first time, I should have started this earlier, the first time it takes a while to load because a lot of libraries are getting downloaded, is my understanding. Thank you. And now you see you see a bunch of applications that are virtualized already for you. I can start up Word. Word is starting on the server now, and you're seeing those UI elements being remoted down to me directly in the browser with no controls whatsoever. That is very powerful. And I wrote something here. WebSockets enables the real-time web. It's standards-based and interoperable, and it's everywhere: client, server, and browser. Okay? And there are other apps you can open as well. Yeah. So you get the point. You get the point that there's that this is an interesting niche that these partners have been able to find for enabling their technologies directly in the browser. With that, I think I'm almost done. So like I said, WebSockets are everywhere. IE10, of course, and other browsers, the Windows runtime, and the Sockets talk. If you want to know more about how we provide support in the Windows runtime, I highly recommend listening to Dave Taylor's talk on Sockets, where he talked about WebSockets. It's especially cool because in the end, he literally fires at people. He has a missile launcher. And on the server side, there's support in System.net, IIS, ASP, WCF. It's very, very cool. So to recap, I said there were 3 things I want you to take away from this. Number 1, WebSockets enables the real-time web. It has a full duplex bidirectional channel with a very simple-to-use API. Number 2, it is standards-based and interoperable. It works across browsers, and we have support for it today. And thirdly, we provide support for WebSockets not just in the browser, but everywhere, so that you can pick your language of choice, you can pick your platform of choice, and provide support in the way that makes the most sense to you. With that, I would like to say thank you. There are a set of related sessions and sites that you can go take a look at. Again, thank you very much, and have a great rest of the conference.